So we're going to be talking about solving linear equations. This is by far one of the most important topics in all of algebra. So this is really important to master. In particular, we're going to be talking about one variable linear equations. And what does it mean to have a linear equation? A linear equation just means that the variable is raised to the first power. Okay, variable is raised to the first power. So I'm going to write out the steps that we use to solve linear equations. It's going to be a step-by-step approach. So step one. Now, by the way, one thing I should mention is that the steps I'm going to write down for solving linear equations, this is going to be for the most complicated type. Now, if the type of problem you're doing is easier, you don't have to do all the steps that I'm doing. You're going to be able to skip some of them. So step one. Use the distributive property to eliminate parentheses. Of course, if you don't have parentheses, you can skip this step. Step two. Now this is a nice little trick. You're going to multiply both sides of your equation by the lowest common denominator, by the LCD, to clear all fractions. Of course, if you don't have any fractions, you can skip this step. Okay, step three. Simplify both sides. In other words, combine all like terms. Okay. Step four. At this point, what you're going to do is you're going to use addition and subtraction. So use addition and subtraction to move all variable terms to one side and all constants to the other side. Okay. Step five. Divide to isolate variable. At that point, you get yourself a solution. You actually get something like, oh, I don't know, x equals a. At that point, you box your answer, and that is your solution. Now, there's a note that I want to mention here. Sometimes all of your variables disappear. Okay, so let me just put that down here. If all variable terms disappear, then what happens is you'll be left with a statement that is true or false. Okay. What do I mean by true or false? Well, when there's no variables in a math statement, in an equation, that means you have a number on one side and then a number on the other side of the equal sign. So either those two numbers are the same or they're not. So if it's a true statement, in other words, something like 4 equals 4, something like that, then this means that your equation has an infinite number of solutions. What you do is you write all real numbers as your solution. Okay? If you get a false statement, for example, 0 equals 3, something like that, then that actually means that you have no solution. Okay, no solution. So this is really important because sometimes you're asked to solve a linear equation that doesn't actually have any solutions, or it has an infinite number of solutions. You need to know how to recognize that. And the key is if the variable terms disappear. One last little note here. We can always check our solution by substituting into our original equation. We're actually going to do that a few times just so we can practice checking, seeing if we get the same thing on both sides. You don't have to check. It is optional. However, I highly recommend doing this, especially on exams when you have a little bit of extra time left over. Instead of just turning your test in, why not check your answer and see how many you got right, and you can go and try to catch your mistakes before they happen. So let me write down a few examples. We'll start off simple and we'll get tougher. Now for all these problems, we're going to solve the linear equation. So example 1, 6x minus 1 equals 17. So we'll go through the steps. So first, step 1, use the distributive property to eliminate parentheses. But there are no parentheses, so we can skip right to step 2. Then it says multiply both sides of your equation by the LCD to clear out the fractions, but there are no fractions, so we can skip this step as well. Step 3, simplify both sides, but look, it's already fully simplified. We can skip step 3 also. Here we go. Step 4, use addition and subtraction to move all variable terms to one side and all constants to the other side. Well, notice that I have a constant on the left and the right, so I'm going to add 1 to both sides of my equation. On the left now, I just have 6x, and on the right I have 18. And notice now, all my variables are on the left, and all my numbers are on the right. So I'm ready to go to step 5. Divide to isolate my variable. Well, I notice there's a 6 multiplied by the x, so I divide both sides by 6. I end up with x equals 3, and this is my answer. I'm going to go ahead and check this problem. I'm going to check the first few, just so you guys see how you would check your answer. What I do is I substitute for the variable in the original equation. Now, I'm trying to find out if this is true. Are both sides equal to each other? Well, by the order of operations, I multiply first, so 18 minus 1, which is 17. And on the right side, I also have 17. That means it checks. So I recommend you do this. If you do this on an exam, you immediately know you got the problem right. Okay? All right, let's move on to the next example. Problem 2. We're going to do 9y minus 8 minus 3y plus 5 equals 21. Let's go through this step by step. We don't have any parentheses or fractions, so I can skip steps 1 and 2. Now, step 3 says simplify both sides. Notice that the left side here is not simplified. So I need to combine my like terms. First I have 9y and minus 3y. That gives me 6y. And then I have negative 8 and positive 5. That gives me negative 3. And I'm done with that step. Step 4, I'm going to use addition and subtraction to move all the variable terms next to each other, on the same side, and all the constants to the other side. Notice I've got all my variables on the left, so I've got to move the number to the right. I end up with 6y equals 24. Finally, divide to isolate my variable, so I'm going to divide both sides by the number next to the y, which is 6. I end up with y equals 4. And this is my solution. Let me go ahead and check this one as well. So I'm going to substitute 4. All I'm doing is replacing everywhere I see a y with a 4. And I'm going to check if that's true. So remember, by order of operations, I have to multiply first. So I get 36 minus 8 minus 12 plus 5. And left to right, 36 minus 8 is 28. 28 minus 12 is 16, plus 5 is 21. So I do get the same thing on both sides, therefore the solution checks. Notice it does not take very long to check your answer. Alright, let's do a couple more. We're going to start to get more challenging here. We're going to solve the following. 7 times 2 minus r minus 2 times 3r plus 8 equals 24. So, starting with step 1, use the distributive property to eliminate parentheses. This time I actually have parentheses, so I have to do that first. So I'm going to distribute the 7. 7 times 2 is 14. 7 times negative r is negative 7r. Negative 2 times 3r is minus 6r. Negative 2 times positive 8 is negative 16, and that's equal to 24. Let's go ahead and combine our like terms here. First, I see constants here. Why don't I do the constants first? I have 14 minus 16, that gives me negative 2. And I have negative 7r, negative 6r, that gives me negative 13r. So now that all my like terms are combined, first I use addition subtraction to get all the numbers on one side. I'm going to go ahead and I'm going to move the 2 to the right. I end up with negative 13r equals 26. Divide both sides by negative 13. I get r equals negative 2. That is my solution. I'm not going to check it this time. I'm going to do a couple more. 9p plus 4 equals p plus 4 times 2p minus 7. 9p plus 4 equals p plus 4 times 2p minus 7. First thing we're going to do is use the distributive property to eliminate the parentheses. So I'm going to go ahead and distribute this 4. Everything else is the same though, so I'm going to go ahead and rewrite the rest of the problem. The only thing that changes though, 4 times 2p is 8p, minus 4 times 7 is 28. Now I don't have any fractions, I can skip step 2. Step 3 says simplify both sides. Notice the right side is not simplified here. So p plus 8p gives me 9p. So on the left I have 9p plus 4, and on the right I have 9p minus 28. So I'm going to move all the variables to one side and all the constants to the other side. So I'm going to subtract 9p from both sides. I end up with 4 equals negative 28. Before I move the numbers around, I should notice something. All the variables disappeared. So the variables are gone. That means I know that this is going to have a special case of a solution. Either we have all real numbers or no solution. So I look and ask myself, is this a true or false statement? This statement right here is in fact false. We know that 4 does not equal negative 28. Therefore, we have no solution. In other words, there is no number that if I plug in for p, I can make the original equation true. It just doesn't have an answer. Let's do one last example. This is going to be a tougher one with fractions in it. So we're going to have 1/9 m plus 1/2 equals 2/9 times 3m minus 2. Alright, so this is going to have a lot of steps involved. Let's start with step 1. Use the distributive property to eliminate parentheses. So we are going to distribute this first. Everything else stays the same, so let's write that down. This is 1/9 m plus 1/2 equals. Now I can put these over 1 just so that the multiplying is easier. Remember now, you can multiply in your head. So 2/9 times 3m over 1, you multiply straight across, you get 6m over 9. And then minus 2/9 times 2 is 4 over 9. Now I know that I can reduce here, right? I can reduce the 6m over 9. It's not really important to do that right now because we're about to get rid of all the fractions anyway. So why don't I go ahead and do that? Let's figure out what our LCD is. We have 2 and we have 9 in our denominators. So the lowest common denominator then would be 18. So what I'm going to do is I'm actually going to multiply both sides of my equation by 18. The way I'm going to write that to make sure that I don't make a mistake is I'm just going to write 18 next to each and every term. It's really good practice to do this. This will help you get rid of small little mistakes. Let's start with the first one. 18 and 9 reduce to 1 and 2. And 2 times 1m is 2m. Plus, here, 18 and 2 reduce to 1 and 9. And 9 times 1 is 9, so we get 9. Over here, 18 and 9 reduce to 1 and 2. 2 times 6m is 12m. And then finally, 9 and 18 reduce to 1 and 2. Negative 2 times 4 is negative 8. Notice why this was a great idea. Now all of our fractions are gone. We can proceed just like we had a regular problem to begin with. So now I'm going to use addition and subtraction to get all my variables to one side and all the numbers to the other. Looking at this, it doesn't really matter. It's not any easier to move the variables to the left or the right, since there's a variable and a number on both sides. So just to be a little different this time from the others, I'm going to move the variables to the right this time. So I'm going to subtract 2m from both sides first. I end up with 9 equals 10m minus 8, and then I'm going to add 8 to both sides. Add 8 to both sides. I end up with 10m equals 17. Okay. Finally, I divide both sides by the number next to the variable, which is 10. I end up with m equals 17 over 10. Yes, it's not a very nice answer this time around, but that's okay. You're not always going to get a nice answer when you do a problem. Box our answer, and we're done with the problem. Okay? Thanks a lot for watching, and hopefully we can tackle linear equations in a masterful way. Thank you.